Welcome to part 2 of vector math. In this video, we're going to use the parallelogram method to find the resultant vector between these two vectors right here. These are the same vectors as I used in part 1. I just want to highlight how the different methods work and I feel like that's most easily noticeable when the only thing that changes is the method. So, in this method, your vectors, instead of doing tip to tail, you do tail to tail. So if I were to redraw that 100 miles an hour, so vector 1, so it starts here, goes over, down 4, so it's going like this. This is 100 miles an hour. Now, this method is we draw the tail of vector 2 on the tail of vector 1. So that one goes, okay, my hand. It goes up 6, yes, 6, okay. So this is 120 miles an hour. Okay. So, from here, we do I guess we'll use green. From here we make a parallelogram where these two is half of the parallelogram. So we're going to draw, okay, so this goes over 3, down 4. So this thing is going to go like this. Oh, that's not in line. So I'm going to do this and this, okay? So we took our two vectors and made a parallelogram out of them. Now, the resultant vector for the addition of these two is this diagonal. The diagonal that comes out of the origin. So there's the longer diagonal here. Since it does not go in, it doesn't go from the origin of the two tails that are together. That is not the diagonal that we care about. There is one, but that's not the one we care about. And since this is a parallelogram, this is also 100 or 120 miles an hour, and this is also 100 miles an hour. Okay? And this angle is the same as this angle, and I guess we'll continue using green. This angle is the same as this angle. I should probably not use a bunch of thetas because there's nothing that says they're the same angle as the rest of it. And then this right here, we'll do a little plus sign. Okay? So those are, because they're all is a parallelogram, that's what happens. Now, we don't know anything else about this, right? We only know the 4 sides, and we know that all of the angles sum up to equal 360 degrees because it's a 4-sided shape. So if we were to zoom in here, okay, we can either look strictly at the bottom half here and solve it the same way we solve the triangular method. Or we could look at the top and solve it just like it's a triangle. And we are looking for, let me do this, we're looking for this angle right there. So, with all of that in mind, we need to figure out what this line is and what this angle is. I'm gonna make this a dotted line. Okay, so this, okay, there we go. How are we going to start this? Well, I'm going to say that we figure out what, we're going to use the bottom again, just because that's where the right angle is. So we're going to assume, I'm going to use a different color here. So that's a lot of green right now. I guess we'll go back to, we'll use orange this time. So this right here is a right angle. So we want to find what this guy is. Okay? And we know that this whole thing is 180, or sorry, is 120. And we can use SOHCAHTOA to find what everything else is. Okay? So if we used, let me write this down, so SOHCAHTOA, okay, using this right angle as our known. Actually, you know what? We're not going to use SOHCAHTOA this time. We're going to use law of sines. So the sine of 90 degrees is over 100 is proportionate to, I guess we can't use that because we don't know one of the sides. Okay. Shall we use law of cosines then? ABC? No, we can't. Okay. Back to SOHCAHTOA. SOHCAHTOA. Okay. So we have 90 degrees and the adjacent or the opposite side. So if we did the tangent of 90 degrees is equal to the opposite over you know what, we'll use, goodness me, I am blanking on this. Okay. We're going to find the components of the 100 degrees, or the 100 miles an hour. Wow. Okay. So this right here is a 3-4 triangle. Because I drew this to scale, and you'll have to draw these to scale whenever you do these kind of methods, you're going to have, oh goodness, this right here and this right here are proportionate to the overall triangle. So since it's a right triangle, we have what is considered a, how do you say, a 3-4-5 triangle. And if we can scale this down here, we get, one of these is 20 miles an hour. Should be, I believe. Let me double check that. Yes, one of those is 20 miles an hour, which means that since this is 3 blocks long, this is 60 miles an hour, and since this is 4 blocks long, this is 80 miles an hour. Okay. And this is slightly different than how we did it in part 1 to find those sides, but since we've drawn it to scale here, we can do this here. Okay? This is just another way to do it. Now, with all of that said, we can figure out what that orange unknown angle is by using law of sines. So we can do the sine of that angle over the opposite side, so 80, equals the sine of 90 over 100. And if we do 80 sine 90 over 100, we get, or no, we sine inverse that, we get what that angle equals. And it should still be 30 or 53.13. So sine inverse, I'll type in my calculator just for the sake of thoroughness. Yep, 53.13 degrees. Okay. So if we look at our triangle here, we can use the law of cosines next. So I'm going to redraw this so it's a little less busy. We'll use blue here. So if I do this, okay, goodness, why do you do this to me, program? So if we start here, go over 3, down 4, does this, then it goes up to here like this. Gosh, okay, and then does that, perfect. So this is R, this is theta, this is 53.13, this is, I mean, if we were to continue this across, if we look over here at this right triangle only, this is 180 minus 90 minus 53.13, which makes this 37.87, I believe. Okay. And now we're going to want to do this. Okay. So we have this side is 100 miles an hour, and this side is 120 miles an hour, and we don't know what R is. And we can't use Pythagorean theorem because it is not a right triangle. But we can use law of cosines. And the law of cosines is C equals the square root of a squared plus b squared minus 2ac cosine, slide over, cosine c, okay? So we do this, and we're going to make R C, okay? So we'll do C, A, B, big B, C. Okay. So we get R equals the square root of A, which we said was 100, plus B, which we said is 120, minus 2 times 100 times 120 cosine of C, which is 37.87. Okay, now all of this will equal 72.11. I will type it in my calculator for the sake of being thorough. And it does, so it's slightly off because of rounding error, but it is 73 point, scroll down here, 85 miles per hour. And the only reason why it's different than what it was in part 1 is because I plugged this right here, I plugged that into my calculator as that instead of doing the full never-ending degree. And that kind of highlights what I was trying to iterate in part 1, where I was saying whenever possible, plug in your whole numbers or use the numbers you were given, because rounding error is can be quite extreme, as you can see here. But we're going to leave it as that for now. Okay. So now that we know what all 3 sides are, we can figure out what theta is. And there's a couple ways we can do that. We're not going to do it the same way we did in part 1, where we looked at the other right triangle. This time we're going to use law of sines for the overall huge triangle. So let me go back to my orange here. Okay, and we're going to have the sine of 53.13 plus theta over 120 equals the sine of 37.87 divided by our R value, which we got to be 73.81 or 85. Okay. And we solve for sine, or for theta. So we get 53.133 plus theta equals the sine inverse of 120 sine 37.87 divided by 73.85. And we get that becomes sine inverse of and this. Okay, so then we're gonna just write theta equals 32.81 degrees. And this method was a little faster than the triangular method, but this method only works if you have two vectors that you're adding together. Okay, so this one is a little easier because you can use geometry and stuff, as opposed to triangular method, which just kind of gets more and more difficult the more vectors you add on, but this only works when you have two vectors. Now, part 3 will go into how to solve the most, I guess, efficient way and the way that is easiest to kind of use, and it's the most applicable, I'll say. But I hope this helped you. I look forward to seeing you in part 3, and if you have any ideas or suggestions for future videos, feel free to leave a comment. And that's it. I hope this helped.